Hello, welcome everybody. Thank you for joining our webinar for today. We're doing our first installment of the Live from the Labs here for 2025. My name is James Gravinsky. I'm the Analytics Sales Manager, and I'm here with my colleague Brandon. I'll let him introduce himself in a second.
Hi, everyone.
And so we are today just demonstrating the KR2i RPM system where we fully integrated the Flow VPX into the KR2i. Go ahead, Brandon.
Perfect. Hi, everyone. I am the Senior Field Application Scientist for the Mid-Atlantic Territory, so my partner is James. And basically today we're going to go over the KR2i RPM system like you mentioned. However, before we actually get into details, I do just want to start the actual process itself because I'm sure a lot of you guys are aware that UFDF does take a while. And so just so we have some data at the end of this and that we concentrated up a good amount, I'm going to hit start right now. So I'm basically just starting the main pump and everything so that while we present to you guys and actually go over the system, we'll actually be able to at least double or hopefully triple our concentration. Okay, so then before I actually get into the system, we're going to have James start with a presentation just for some of the basic knowledge of our technology at Repligen. So I'll let James take it away. Thank you.
Perfect. Thanks, Brandon. So I'll give it 1 second here for the slides to load up. So again, as I mentioned, I will talk about how we transformed the UFDF process with an automated PAT-controlled TFF system, which in this case will be our KR2i RPM system. For the quick agenda here for the next few minutes, I will talk about market needs and challenges, some system highlights, a technical overview, and then I'll talk about concentration control versus mass balance control, which is basically the big differential between incorporating the Flow VPX into your TFF system. Lastly, there the topic questions. So you'll see the box on your right in the go-to webinar. Please feel free to type any questions you have at any point in time to get some questions in our system. And as soon as the whole demonstration here is completed, we will then start answering everyone's questions as well. So challenges with TFF. A couple of years ago, in one of the latest surveys of biomanufacturing folks, they did a survey to kind of assess what market needs or new product areas of interest are kind of what people want to see on the forefront of technology. And as you can see, when you really look at these bars, a lot of them kind of relate to PAT tools, automation, instrumentation, and analytics. And I hope what you will find as you look at all these different bars and hear about the Flow VPX system, that you will find that it embodies most of these, if not all of the graphs. So current challenges with TFFs, everybody is very familiar with it being very mass dependent. So with mass dependency, you have your hold up volume calculations and even the non-one weight of water that is assumed. So there's a lot of assumptions and things like that that go into the mass dependency that you can eliminate those errors by going straight off concentration. TFF is also a fragmented process. As you know, you've got your weigh scales, you've got your pumps and your sensors and everything in there. And so having them all communicate with each other can really help bring the fragmentation of your TFF process together to work in unison. And then variability, we know that, as I mentioned in the other two buckets, that it's very dependent on mass, and even a singular variable that has inconsistency can lead to very inconsistent results. Ultimately, all of these culminate into kind of a risk of error, whether it's hold of volume calculations, various dilution steps, analysis delays, all the human interactions that go on within your TFF process introduce error into the process. So what we're looking to do here is holistically eliminate a lot of these manual processes. So I'll introduce you to kind of the components of the KR2i system next. So what you see here pictured on your left is the KR2i system, and on the right our Flow VPX system. So basically what we've done when it comes to creating the RPM system is we've fully integrated the Flow VPX into the KFCOM2 software of the KR2i system and plumbed it straight into the into the feed, into the circular loop of your product, so that you have the ability to monitor your process in real time and get a full understanding of what's going on at any given time within your TFF process. So here's just a few quick highlights for those that are not familiar with the KR2i KrosFlo system itself. So the system itself was built to have walk-away automation with about 13 automated process control modes and manual operation for basically a process development. It's got a very robust processing dynamic range, going from hold volumes down to about 10 mils up to handling about 10 mils of initial feed volume. It is designed to be, as I mentioned, the semi-automated system. One of the big control factors is a automated back pressure valve, which helps control your TMP automatically. And a lot of that stuff here is all controlled through the tablet listed in the center there. With the Flow VPX system, for those that are familiar with the Solo VPE, we've basically taken the same slow spectroscopy methodology and applied it to a flow-through system. What you can see in the picture of the Flow VPX here is that you've got on the top, you've got a head. That controls the flow cell and everything, and then you've got the flow cell in the center there, where you can see it's got this flow cell that's pictured has a tri-clamp where your material flows through, and then on the bottom you've got a detector plate. So the Flow VPX is designed to be a full uv-vis spectrophotometer, not any sort of sensor that one will experience with a lot of other sensors that have been implemented into the TFF process. With the Flow VPX, we've got a broad dynamic range, so it allows for concentration measurements down to about 0.1 mg per mil, up to and even exceeding 300 mg per mil. We've also got better accuracy with comparing to the Solo VPE or any other uv-vis spectrophotometer. We will always claim to be within that 2% repeatability and everything as well. I do want to quickly mention before I go to the next slide that not only is the Flow VPX available with the KR2i RPM system as well as other RPM systems that I'll touch on later, but it is also available as an a la carte tool that can be plumbed into many other processes other than TFF. So what is slope spectroscopy or variable path length spectroscopy? This slide kind of highlights it very well, where you see on the left you've got your traditional uv-vis spectroscopy, and on your right you've got variable path length. So with traditional uv-vis spectroscopy that most people are used to, it obeys Beer-Lambert law, where your absorbance equals your extinction coefficient times your path length times your concentration. And with traditional UV specs, your path length is typically fixed, either a 1 centimeter / 10 millimeter cuvette or some other iteration therein. And so regardless, what you have with a fixed path length spectrophotometer is you need to manipulate the concentration of your material in order to fit with the linear range of the spectrophotometer. And so we noticed that there was a lot of limitations with that and a lot of errors that can be introduced when you are manipulating your sample in order to fit the linear range of your spectrophotometer. So when you look on the right with variable path length spectroscopy, what we're doing here is locking the concentration and unlocking the path length. So with basically changing the path length in which you are shooting light through your sample in through the detector, that you are allowing the concentration to be fixed and you're removing any sort of dilution variable. When you apply this to the Flow VPX system, nobody wants to purposefully change the concentration of their material directly in their bioprocessing workflows in order to fit within the linear range of an analytical tool that they have plumbed in. So this basically allows you to continue to be free with your process and ensure that you're getting good analytical data out of it. So how does the Flow VPX work? So a lot of the times when you take an analytical measurement, you get an absorbance measurement, and then you get basically a data point. With slope spectroscopy, what we're actually doing is finding one absorbance unit and taking 10 iterative measurements moving down in path length to create what we call a slope. So when you see in the right-hand side of the graph here, this slope has linearity and also an R² value that's attributed to it. Our passing grade is 3 nines or greater, and so we look to have each data point have a linearity measurement and pass or fail even for the data point itself. So what you will get, instead of just a singular measurement with the FlowVPX, you will get up to 12 measurements per minute, depending on how many slope points you decide to put on for each of your measurements. With getting 10 measurements a minute, up to 12 measurements a minute, you can then get a concentration versus time curve as depicted below. And so when you look at this concentration versus time graph, this graph that's here is actually very representative of a standard UFDF process where you have a feed stream where you're concentrating up and then switch over to diafiltration and then concentrate up again. Here you can see when you go from 10 to about 30 mgs per mil, you concentrate up at kind of a lower rate until your feed material runs out. Once your feed material runs out, you concentrate up at a little faster rate, switch over to diafiltration at 40 mgs per mil. Once diafiltration's done, concentrate up to that final concentration target.
Thank you. Actually, James, since you just brought that up, I did want to bring up our first poll question for the audience.
Sure.
Is how familiar are they with the VPT technology, meaning the Solo VPE and the FlowVPX? So on your guys' screen, you'll see a poll question that comes up. If you guys could just please answer that, and we'll come right back to the presentation in 1 minute. So James, actually, while everyone's answering this poll question, I did just want to talk about a little bit what's happening in the system back here. So for everyone's information, we actually started with 25 mg per mil BSA with an extinction coefficient of 0.667. So that's the material we're using today. We're not doing any diafiltration to save time, and our goal is to concentrate up to 75 mg per mil. So I'm sure while you guys were listening to the presentation, you saw a graph in the top right corner. That's actually the graph projected from the KR2i RPM system onto the PowerPoint, so you can see the concentration in real time. We started at 25 mg per mil, and we're currently at 32 mg per mil. However, though, we just hit our TMP, so we should be speeding up soon. So then I'll hopefully let James cover the poll questions now if everyone's ready.
Perfect. Thanks so much, Brandon. Yes, so it looks like from our poll, approximately half of the attendees are familiar with variable path length technology, a little bit less familiar with the FlowVPX system, and a few familiar with the KR2i RPM system. For those that are unfamiliar with variable path length technology, definitely feel free to reach out to us. We'd be more than happy to explain it to you in greater detail, give you an introduction into how our technology works and the benefits that our customers receive compared to traditional uv-vis spectrophotometry. One of the benefits that people will see in general is applicability to a wide range of applications. So you can see here that we've got our Solo VPE Plus, which we've newly launched to replace our Solo VPE system, but basically our Solo is kind of our at-line system where you take measurements and then get a singular concentration reading, and then below it our FlowVPX, which was our iteration of inline. And so you can see on the right the various applications that we have developed and have publications and or white papers on them, ranging from cell culture density using OD600 through plasmids, mRNA, DNA, MABs, we do ADCs, etc. So almost anything that you would analyze through a normal uv-vis spectrophotometer, you can definitely do with either the Solo VPE or FlowVPX system. Again, these also have a harmonized platform across various functional groups and process alignments. So as I mentioned, going from cell culture upstream all the way down to your formulation and fill finish processes within your bioprocessing workflow. The Solo VPE as well as FlowVPX have been implemented across the board. And also when it comes to functional alignment, all the way from process development through MSAT and manufacturing. The only thing you'll notice is the FlowVPX isn't really a quality control tool. Most of those systems are all offline, but as soon as you bring everything in line to the various disciplines, the FlowVPX has shown applicability. just some quick highlights about the features of the FlowVPX system. As you've probably seen in the images that we've been presenting here, it's a GMP grade system. It's made with 316 stainless steel. It's IP65 rated. It's got the CE marking and everything to be implemented into a GMP manufacturing environment. You can kind of just spray it down, use any cleaning methods you want. I mentioned the increased dynamic range already, going up to and even potentially above 300 mgs per mil. A lot of that depends on your extinction coefficients. Scalability, there'll be a little bit more on this on the next slide, but basically our FlowVPX is scalable all the way from the bench size, which you'll see here today, up to even manufacturing scales, all with the same VPX head, just changing out the flow cell. The next picture you see on the right of that is kind of a cross section of the flow cell where you can see the optical fibrette dipping up and down within the piping range of the FlowVPX system. And we did a lot of back pressure measurements here to ensure that we are not obstructing the flow path and causing any sort of fluid dynamic concerns. Connectivity, so we've got the FlowVPX here integrated directly into the KR2i, but for anybody using it a la carte for various other applications, we've got analog output channels as well as OPC UA to fully integrate this into whatever workflow and any sort of automation platforms that you're potentially using as you scale up into manufacturing. The last one there, flexible placement. The system comes with a mount. That's what you'll see today. But there's also just a couple screws on the back. You can take the system off of the mount and directly mount it to any skid or any sort of workflow that you're looking to integrate the system into. So the next slide here talks about our flow cells. So what you'll be seeing today is us running with the 3mm flow cell. Underneath all these flow cells, you can kind of see what kind of fittings you have, your max flow rates, your pressures, and your hold-up volumes. So you can see here we've depicted our 3mm, 10mm, 22, basically going up from development pilot through to production scale. We also make 1.5 and 2-inch stainless steel flow cells as well. We've also launched our single-use flow cell line very recently. These can come just as they are, or they can come X-ray irradiated as well. And these again are in the 3, 10, and 22mm sizes. And the flow cells here are made with PPSU as opposed to stainless steel. So next I'll kind of get more into the actual RPM system. Brandon will talk to you about all the components and everything that you kind of see on the graph here. Mainly what I just want to highlight here is all of the integrated data analysis and everything that you will get from it, as well as the concentration insights. So as you go through your process and you're running any sort of UFDF using the KR2i RPM, any sort of deviations in what you would expect to see as you're running your process, you can definitely see that in real time and make any sort of adjustments on the fly to your process using these feedback controls to ensure that your UFDF process goes smoothly. And then with integrated data analysis, you can definitely pull your data, manipulate your data to ensure that you're presenting exactly what you need to there. I'll go to the next slide here, which will again highlight that not only are we showing you the KR2i today, but we've also fully integrated the FlowVPX into these other systems that are commercially available. So our FS15, which is our quattroflow pump version of the KR2i system. In the future, we will also be integrating these into the larger scale KMPI and FS500 systems. And then on the bottom, we've got our line of RS systems, which are our fully automated production scale systems, ranging from our RS10 all the way up to our RS50, basically going from the RS10 being more of a fully automated developmental scale system that can also be used for manufacturing things like viral vectors, all the way up to our RS50, which is basically put into manufacturing suites. Next slide here. Also, Repligen does not just sell systems. We also have a lot of consumables that we have available on the market. So what you'll see today is us performing a UFDF process using one of our Tangential flat sheet cassettes. We've got flat sheet cassettes in a wide range of sizes, of pore sizes, as well as surface areas. And then we also manufacture hollow fiber filters as well. So if you need hollow fibers for your materials, they're definitely available through us as well. On the bottom, you can see single-use components and equipment. So we've got an entire fluid management division that is dedicated to providing any solutions that you need. So here you can see things like bottles, dip tubes, funnels, etc. But basically any potential fluid management need you would have, definitely reach out to us. We'd be more than happy to hear about what your pinch points are, what your needs are, etc., and develop a solution for you. Lastly, on the right, we've recently launched our ProConnex self-assembly kits. So these basically come with all of the materials that you would need to connect up to a KR2i. They include things like your filter, your bottle, your dip tube, all of that. So we have the self-assembly kits, and then we also have the fully assembled plug-and-play kits as well that are available, and these can come irradiated or non-irradiated as well. So then, quick technical overview of the KR2i system, of the RPM system. So where this all really comes together is in the software. You can see by this kind of circuit diagram, you've got your reservoirs, your pumps, your filters, your scales and everything all connected to the computer itself. So this computer is essentially controlling all these various systems to ensure your TFF process goes smoothly and in a harmonized fashion. So what you'll see as Brandon goes through creating a system, for those that are familiar with the KR2i and the KFCom software, you're used to the screen that you see on the top with setting mass balance targets. So you can see you've got the permeate scales checked off, and then you're going by concentration factors. So basically it zeroes out that scale, and then once it hits, as you can see, 6 or 24 times that concentration factor compared to what it sees on the scale, then it will switch over to your diafiltration or stop your concentration process. And as we know, as you do hold of volume calculations, as your material gets more dense, as you lose stuff through your permeate, etc., these can provide small amounts of error that can lead to you not actually hitting your desired concentration target. So when you switch over to using the VPT device on the bottom half of the screen, using the FlowVPX to determine your targets, you can actually input your exact concentration targets that you want to hit. What you can also see in the middle with your diafiltration mode is, while you can go by diafiltration volumes, and that is fairly common, you can also use conductivity. So we've got a conduit that you can also connect to the KR2i system, where you can connect a conductivity sensor and measure your diafiltration through conductivity. Here's another quick graph on the UFDF process. It's very similar to what I kind of described to you guys a few slides ago, where you've got your concentrating up, your diafiltration, and then your C2. But what you can see here is one of these, the same process was run here using a mass balance and then monitoring using the VPX so that we collected data, and then the other one using the FlowVPX to control the system. And ultimately, as you can see, it runs in a more efficient manner and also hits the target the first time without potentially exceeding or undershooting a target, where you then have to make adjustments to your process later, which then takes time and decreases your overall efficiency. How do we make sure that we're all in line? So we made sure that we tested the FlowVPX across our solo VPE as well as compared to fixed path length spectrophotometers. Make sure that all of the data kind of lines up very well and is in sync with each other. You can see here. We'll go to the next slide. So in conclusion, what you can see here, what I hope you will see in this live from the lab demo and at any other points in times with your interactions with the KR2i RPM system, is that this TFF system can strengthen your process controls, increase your efficiency, and reduce your risk through your TFF process. And this can really allow you to get from the bench all the way through to the manufacturing scale in a lot faster time and a more efficient manner.
Perfect. Thank you so much, James, for that presentation. So now we're actually going to go straight to the system. And basically, before I get into the actual system, I do want to remind you guys that please feel free to ask any questions in chat. We will have time at the end to cover all questions, hopefully. But basically, we're going to start from the left side here and actually just go over each part of the system. So on the left, this guy right here, this is our KR Junior pump. This is basically an aux pump used for diafiltration or constant feed. You could have two of them for the actual system. Then we have the feed scale, which measures the weight of how much material we actually have in our retentate vessel. So like I said, we're using BSA today at 25 mg per mil. Well, currently it is already at 50 mg per mil. So we actually did concentrate 2x already, which is nice. Then moving over, we have the Flow VPX, which is what's actually controlling the whole process today. So we're controlling the process off of concentration instead of concentration factor or off of the mass balance. So what's nice is what you'll see me today is we'll not touch the system at all. The Flow VPX is going to do everything. It's going to concentrate up. It's going to stop the main pump once it reaches the concentration and actually end the run for us, which is really nice. Moving over, we have the main pump, which is currently flowing at 120 mils per minute. And it also has a bunch of pressure sensors. So it's telling us the feed pressure, the permeate pressure, the retentate pressure, and the TMP. So we're running at a 10 PSI for TMP. We have our flat sheet membrane cassette holder, which is, again, like James mentioned, I'm using a flat sheet today. However, you do have the ability to do hollow fibers. So we have a few consumables to show you today, just from the lab.
Absolutely. So what you can see here is I'm holding here our Tangential flat sheet cassette. These come in, as I mentioned, in a wide range of pore sizes as well as surface areas. This one's 100 kilodalton, 0.01 meters squared. Brandon's using a 0.02 meters squared filter. And then we've also got our hollow fibers here, which you can basically put into this holder to set your cassette here. So again, offering both systems. And then lastly, what I can also show you is a quick depiction of what our ProConnect's flow paths kind of look like. Here's ones that come bagged up, but basically all of the separate components are all contained within the singular packet. You just pull them out, assemble your flow kit, and you're ready to go. Go ahead, Brandon.
Yep, and that's if you're going to want to use a more sterilized process. However, since again we're non-GMP and just using BSA for this test run, I just cut the tubing myself, and again, nothing I'm using here is very sterile. So after the flat sheet membrane, we have the retentate scale. So again, or the permeate scale, sorry, just measuring all the waste. Normally, the scales would be used to control the process, but like I said today, we're going off of the Flow VPX. But the last bit I did want to say, which is special to our system, is this guy right up here. Oh, sorry. Okay, perfect. This guy right up here, which is our automatic back pressure valve. So this is an automatic clamp that's going to push down on the retentate tube, so to cause the TMP to be at 10 PSI. And again, this is controlling TMP automatically. So you no longer have to adjust your clamping or anything. What's going to happen is this is going to control the pressure, and then it's going to release on the retentate tube as you get concentrated higher so that it remains at the 10 PSI the whole time, which is nice. Okay, so now I'm going to go into the software to show you what's actually happening. So as you can see here, this is our concentration graph. Again, we started around 25 mg per mil, and we're just hitting 60 mg per mil right now. The goal of this recipe was to stop at 75 mg per mil. But what to show you what the RPM software actually looks like. So here is, on the left side, you have a few different modules you can go into. So trial logs is where all your data saves. System logs is the audit trail for the instrument. Recipe list, this is where you're going to make recipes to control your process, which we'll go into after. then trial run, which you have auto mode, which is what it's currently doing, is if you make a recipe, it will automatically run off of that recipe and control the system for you. And you don't see it now because I'm currently doing a run, but there's also manual mode. So you can do a fully manual method if you would like to do so for like cleaning, filling the tubes, doing any experiments that you need more like free operation for. Okay, so for the recipe list, if you go in here, it has all the recipes that I currently made, but you can press add to make a new one. It's going to ask you for a name, and then it's going to give you the mode. So these are the automation modes that James brought up. We have a bunch of different ones. C stands for concentration, D stands for difiltration. You have a bunch of different pairs. You also have CFCs, which is for constant feed concentration. What I'm doing today is just a concentration step. And again, as you can see here, you have permeate scale, so you can go off of the weight like normal, or you can click on VPT device, which uses the flow VPX to base it off of concentration. So all I did was type in 75 mg per mil, and it's going to keep concentrating until I get there. Okay. So then you have a pump type. So what's nice about this system, or the RPM systems I should say, is the flow VPX can be added to any 4 of these, and it uses this automated software. So the KR2i, the KMPI, the FS15, and the FS500. Basically what the difference is the sizing. The KR2i and the KMPI both use a parasaltic pump, but the KMPI is larger. The FS15 and the FS500 both use a diaphragm pump, and the FS500 is the larger version of the FS15. Okay, so then I just got to choose a bunch of options, the tubing size and the flow rate I would like to run at before going to the next page, which then you would click on hollow fiber or cassette. If you use a Repligen hollow fiber or cassette, it would automatically fill in all of the numbers by choosing what cassette you're using, which is nice, and you just have to choose how many cassettes you're using. Then we have aux pumps. Again, since I'm not doing difiltration or constant feed, I am using 0 aux pumps, but you can have 2 on the system. Then we have the ABV. This is the automatic back pressure valve that I mentioned before, which you can control off of TMP and do auto. And all you have to do is put in what TMP pressure you would like to run at, which is 10 PSI for myself, and keep it open. Okay. Then the tubing size you're using. We're using size 16 today. This is the conduit that James mentioned. Basically, again, we're not using it today, but if you would like to, you can press yes, and this could do conductivity in real time as well. And then the last page is the recipe page for the flow VPX. So this is just where you're going to choose your flow cell size. So today, since we're doing a lab scale process, I'm choosing the 3mm flow cell, and you can do multiple wavelengths at the same time, but since I'm just reading a protein, I'm going to be doing 280 at 0.667 extinction coefficient. Okay. And then on here is something we don't really recommend changing. This is our search algorithm for both the Solo VPE and the Flow VPX. However, if you would like to change this to match your process more, you could always work with me. That's part of my job roles, is to help you guys post sales to maximize the efficiency of your process. Okay, so that is making the method. Okay, but like I said, we are already running one, so I'm going into the trial details. Oh, actually, if you see right here in the top, it says collecting data. That's because the run just finished. So if we can zoom out from the software and actually look at the hardware right now, you can see that the pump stopped and basically nothing is flowing anymore. That's because we hit the 75 mg per mil, and we can look at our data to see if it actually stopped correctly and our process is finished. Okay, so let's go back into the software. Perfect. So again, this is where the system recipe is loaded, and it says all the parameters that I was using for it. And you also have a bunch of alarms. So for feed weight, permeate weight, feed pressure, and permeate pressure, and concentration. So if you want to make alarms to either stop the system if you get to a certain level, or just to alarm so that you know you're at a place. This is the flow diagram, which it normally tells you what's exactly happening in the run, but since the run just finished, nothing is going on. We also have the tables, which is what's going to give us a bunch of data. The tables is the section I usually like to stay on. And this is what's going to show the most amount of information. It's going to show you the concentration in real time. It's going to show you the pressures. It's going to show you the P permeate, so how much fluid is going into the permeate section so that you know how fast your process is going and everything like that. Then we have the graphs, which you can see here, concentrated up. So I just saw in the table section, but if you look here, the concentration ended at 74.6. So again, we must have had one data point over the 75, and then it dropped back down during recirculation mode. But again, as you can see here, we're definitely within the 5% of what we wanted to stop at. So I'm quite happy with the results. It just concentrated at 75 mg per mil right by itself. Then here's the P and ID, which again tells you everything that's happening in the system. Lastly,
so Brandon, quick question. Does this also help kind of eliminate offline sampling?
It does. So I'm actually going to pull up a poll question right now to ask how much of you guys actually sampled during a UFDF process. But because of the fact that the FlowVPX is inline and getting concentration in real time, as long as you validate the method, you no longer have to take samples for your process, which kind of saves a lot of money and time, which is nice. So yeah, please, we have this question of how many samples you take during a standard UFDF run, and basically, I'll just give you guys 1 minute to answer this, and then we'd get back to showing you the data.
Absolutely, and then also as you're filling out your poll questions, again, we'll kind of quickly reiterate that we've got the question field open, so definitely feel free to continue to populate your questions in here so that we can answer them when we get to the question and answer session. Anything else on this screen you were looking to highlight?
No, I was just showing the end of the software before the poll question came up.
Right.
But we only have 2 more sections to go through.
Sounds good. So looking at the poll results, it seems like people typically sample anywhere from 2 to 3 all the way up to 6+ samples during their UFDF run. And so I think one of the things that, it really ponders the question of, if I was able to put this in line and really only take one offline sample, how many cycles of UFDF runs would I be able to accomplish compared to a lot of the times, depending on where you're sampling, how you're sampling, and who's performing the analysis, it can take a long time to get the results that you are needing in order to feel comfortable moving on to the next step.
Yeah, definitely. With most of my customers that use the FlowVPX, of course this depends on your lab structure, but if you have a solo VPE in lab, of course it just saves time and money than running the samples, but some people don't have the ability to run samples in their lab and have to send it to, say, a QC team, which can take hours or even days depending on what type of material they're using, especially if they're doing, say, PCR for a different type of material. But yes, so it definitely will save a lot of time on that aspect. But as you can see, it also takes away the human error. So by the fact that I was controlling off of concentration, I did not have to worry about the mass or what the scales were reading and if someone bumped into it or placed something on the scale or if the tubing got loose, because again, I know that the FlowVPX is reading concentration in real time and going to stop the process when it needs to be stopped. So that kind of brings us to our demonstration today for the actual run. However, I did want to see if you guys had any questions that James could read off to me. And I did also want to mention that we do free demos with the FlowVPX. So if you either want to try it with your material, within your process, we can put it right on top of one of your UFDF systems or even chromatography systems, or we can bring a full RPM KR2i system as well to do the full UFDF system for you. Thank you. So,
yes, definitely feel free to reach out to us if you have any interest or would like to hear more. Yeah. I'm going to grab my computer quickly and take a look at some of the poll questions that we have. So first question that I have here, will A280 and A260 work on the system?
Yes. So what's nice about the FlowVPX and with the KR2i RPM software, you can do multiple wavelengths at the same time. But we also have a software called Viper, which is the software that controls just the flow VPX, which can do up to 10 wavelengths at the same time and even do spectrum scanning if you need to. If you were going to use the KR2i RPM software, we do have built-in different methods so that if you want to do 260 and 280, say specifically for AAV, you can find out your genome titer and your capsid titer. You can do 260, 280 of just mgs per mil as well, and do the ratio all built in, which is nice.
Thank you, Brandon. So next question here that we've got is what is the highest flow rate the VPX can be used with, and are there different piping sizes that can be installed on the VPX?
Yep, so if we can actually zoom into the flow VPX, I can show you the part that changes. So right here, this is the flow cell. So the flow VPX will always stay the same. This part will be removed and changed depending on the process of the size of your process. So like I said earlier, this is the 3mm flow cell used for lab scale, but this can go all the way up to 2 inches. So if you need to go to a larger process scale, let's say you're running up to 350 liters per minute, you can do that. This guy's rated for only 1.5 liters per minute. And again, but like I said, if you want to use a larger flow cell, the 10mm, which is almost equivalent to a 1/2 inch, the 1 inch, 22mm, we can go much, much larger. So I actually have here today, right now, is the 10mm flow cell. So as you can see here, it is much larger, but this would be our pilot scale. So this can go up to 20 liters per minute for flow rate. All of them are rated for 80 PSI in pressure. But again, if you need to go to a higher flow rate, then you just up the flow cell size, which our largest would be the 2 inch. Thank you.
Great, thanks, Brandon. The next question that I have here is related to these flow cells. People are asking, are the fibrettes disposable? They're used to, I think they're used to solo VPE measurements.
Yes.
And they're asking if the fibrette is disposable.
Yeah. So what is nice is about the flow VPX compared to the solo VPE is it uses the stainless steel flow cell. Of course, we do have the option to use single-use flow cells, but this flow cell is reusable, it's cleanable, so you can use CIP in place, so you can clean in place, or you can do SIP, which is steam in place. You can autoclave them if you want to. But basically, as you can see here, for the reusable ones, everything is stainless steel, even the fibrette itself. Here is a single-use option, which is PPSU, if you would like to use that. And you also can see it has the septic connected to it so that it can stay clean. But yeah, so this guy's fully reusable. You won't have any consumables like the solo VPE. We usually rate this for 500,000 cycles, which if you did like a 6-hour process, that would be about 3,000 measurements, so 3,000 cycles in that one process. So they usually last a year or a little bit longer. Thank you, James.
Great, thanks, Brandon. Next question I have here is, can I use the flow VPX in single pass TFF or inline diafiltration processes for continuous manufacturing?
Yeah, so I actually have a few customers that use the flow VPX for single pass or say continuous chromatography. Again, you would either just put it before or after the single pass membrane if you want to know the concentration going into the membrane, or if you want to know the concentration coming out of the process. You can use that to help control the process, which is quite a nice tool. You can also get 2 of them if you wanted to put it before and after the process, but that's not totally necessary. And again, a lot of customers also do it in formulation, so they're diluting down to know the final concentration, and we have that in commercial manufacturing right now, which is nice. So a lot of people use it just to see their final concentration before going to fill finish, and so that they know that their exact concentration when they collect. So there's no more getting too low in concentration and have to reconcentrate up your batch or waste a batch.
Great. Thanks, Brandon. So the next question I have here is related to higher concentrations. So the question asks, we're able to go up to and even above 300 mg per mil, but a lot of the times when I hit 200 mg per mil or more, I start to get a lot of micro bubbles. And is there a way to avoid having the bubbles either sucked into the sensor or causing an issue with measurements?
Yeah, so that really depends on also a volume slash viscosity issue. So, I mean, if you have plenty of volume and your dip tube is under that, you should have no problem having no air into the system. Again, also, it could be how fast you're mixing if you do have mixing in the retentate vessel. So that can cause air bubbles, but as long as you slow down your mixing to the lower volume that you're measuring at when you get to, say, UF2 or concentration step 2, you shouldn't include air bubbles. And as long as the air bubbles doesn't get aerated and they just pass by, it won't affect the system when reading concentration at all either.
Yeah. Great, thanks, Brandon. You also asked, there was a question about mixing, but I think you kind of asked that question. I don't know, answered that question in that question, so I don't know if there's anything you want to add about mixing.
Yeah, well, again, mixing is something we highly advise when you're reading concentration inline, just because you want to read homogeneous samples. So basically, as you can see here, I have a magnetic stir bar inside the vessel holder because I want to make sure that everything's homogeneous when it comes to the flow VPX. If not, you can see variability when reading concentration.
Perfect, thank you. And then in the TFF process that's been optimized in PD, what are the limits in terms of like sample viscosity and concentration?
Yep, so again, we've read up to 50 pascals for viscosity and everything, and as long as it's still flowing, I say, usually you have no problem. Because the flow VPX works on a stepper motor, it's going to drive to the path lengths that it needs to get to the concentration and read it accurately. So usually we have no issue as long as it's flowing.
Great. Great.
And again, as long as the pressure is below 80 psi, we should be fine.
And next question asks more about processing volumes. When it comes to like this system and then the larger scale KMPI systems, what kind of processing volumes can we do, basically from max to min?
So again, for the smaller system, I would say you can do probably anywhere from 10 liters and lower, just because the max flow rate of this guy is a little bit over 1 liter per minute. Of course, it depends on the tubing size you're using. For the KMPI, you can go larger. Again, it really depends on how fast you want to go. But I would usually say, like, what would you think, James? About 30 liters or lower for a process for the KMPI?
Probably for the KMPI, yeah. But we also have other FAS experts that we work with as well. They're experts in the TFF process. So if you have any questions on those, please feel free to reach out to us, and we're more than happy to answer those for you.
Yeah, and we also have the FS500, which again is the same, very similar to the system, just a diaphragm pump that could even go larger too.
Perfect, sounds great. Thanks, Brandon. And then lastly, I see there's a question here about the back pressure valve, and if you can use it to help control your TMP, and at what point do you kind of saturate the back pressure valve? Yep,
so actually I use the back pressure valve to control my TMP fully. So what's going to happen is in the beginning of the run, I'm going to keep it wide open, right? And I'm going to let it sense how far it has to go to closing to calculate or get to the TMP that I want. So what's going to happen is if I start at 25 mgs per mil, the back pressure valve is going to close to say about like 35 to 40% of the way until it's touching the tubing until it gets to 10 psi. And what's going to happen is as I get concentrated, the pressure goes up. The automatic back pressure valve is going to go up and up a little bit until you get very concentrated, let's say over 200 mgs per mil. Then what's going to happen is the automatic back pressure valve is going to go up all the way, releasing the tube, and your TMP is still going to hold at 10 psi because of the pressure of how concentrated the solution is. After that, the pump has an option of slowing down to keep the TMP at what you want it to be at, which is nice, depending on how high your concentration is. But that only happens with a very high concentration. The rest would be all based off of the TMP automatic back pressure valve, which, again, unlike a standard valve that you have to control in process and tighten yourself, it's going to do everything for you. You should not have to touch anything.
Great, thanks, Brandon. I got one more question here. and it looks to ask about background correction. The surveyor has a question saying they do background correction normally with their measurements, and how do you accomplish this here with the RPM system?
Yep, so of course, the Flow VPX has the ability to do background measurements. You would just have to run, say, your buffer or whatever you want to baseline first. Then it's going to store that into the system and then use that to get concentration based off of that baseline. However, we are slope-based, so we do slope spectroscopy. So I normally say to customers, especially if they have a solo VPE and they can just do it offline, is measure your baseline or anything that you think that absorbs at the same wavelength you want to read. And if it doesn't give you a slope of 0.001 or higher, then that means you do not need a baseline. So the whole point of the slope spectroscopy is it does not matter if you start at 0 absorbance or 0.5 absorbance. The slope stays the same. That will only change is if, say, if you have something in your buffer that will absorb at 280 nanometers and you're trying to read at 280 nanometers. But besides that, normally baseline correction is not needed. But we do have the ability to do it if you need to.
Great. One more question that I have here. How does the conduit work with A280 and A260? I think we can answer that question both with the VPX as well as the permeate sensor, right?
Correct, yeah. Yep. So the Flow VPX, of course, is going to do the concentration for you inline. So if you want real accurate measurements all the way up to over 300 mg per mil, the Flow VPX would be your best option. However, that's going to measure your concentration on your feed line of the material. If you want to see something like on your permeate line, just seeing if any material is going into the waste bucket, we do have the ability to do a small UV sensor on the side with the conduit so that you can just say like yes or no if protein's actually escaping or not. But if you want real concentration measurements up to a very high range, the Flow VPX is going to be a better option. But you could use both with the system. Like I said, put one on your permeate just to see if anything's escaping, and then one to actually control your process with based off of concentration.
That sounds great. Thank you so much, Brandon. I don't see any other questions coming in, so if anybody has any last questions they want to ask, I'll ask you to enter them in the next few seconds here. But I want to take the time to thank everybody here for listening to us and attending our first Live from the Lab webinar. We'll also have one coming up soon for our Solo VPE system, so stay tuned on that. Brandon, did you have any other closing comments that you'd like to make here before we go?
Yeah, I just wanted to mention and reiterate that, again, we do demos all the time in our territory, which would be James and I. However, if you're based anywhere in the UK, overseas in Asia, or anywhere in America, we do demos for the Flow VPX. So like I said, please feel free to reach out to us if you would interested in trying it in your own process. I think it helps a lot of people to see how it works with their actual material. But yeah, no, thank you so much for joining. I hope you guys learned a lot, and I hope you guys got to enjoy seeing the system.
Thank you again. I hope everyone has a wonderful remainder of the day, and we look forward to working with you soon.